Hello everybody and welcome to my session about live tiles and push notifications in Windows Phone. My name is Erez Harari and I am the CTO of Sela Canada, and I've been writing code for most of my days ever since I was 11. I've been working in the high-tech industry ever since I was 17. I've done quite a few roles over the years. Of course, I've been a developer, but also program manager, project manager, CTO, and VP R&D, but never have I raised my hands from the keyboard as a programmer, code programmer. In our world, it's customary to classify developers as to be server developers or client developers. Well, I'm a little bit different in this area, because I could be easily classified as a server developer, as I specialize in server technologies such as data technologies, entity framework, SQL Server and Oracle, communication technologies such as WCF, etc. But I also manage quite a few projects, and I've been a CTO of a company who did projects in web development. But that said, the best thrill for me is gaming and game development, which I do in Windows Phone and for the Windows 8. Actually, you could find, I was part of the small group who created the demos and training kits you can find in App Hub for the XNA Windows Phone development. If you go to the App Hub, you can download them. So what are we going to do today? Today we're going to talk about push notifications and live tiles in Windows Phone and see this very exciting way to bring your phone screen to life. Let's see our agenda. Oh, I'm sorry. Okay. So, what is going to be the agenda for today? First, we'll ask, how does a Windows Phone application work? It's very important to understand how a Windows Phone application works. And before we go and dig further, we'll ask what is a Windows live tile, what is a live tile, and I'll explain about push notifications. I'll show the structure and the types of push notifications. We'll see the stages in creating live tiles, and we'll see a lot of code, quite a few demos, because code is what we really do most of the time, and of course a summary. So without further ado, okay, how does Windows Phone application work? Well, Windows Phone, being a phone operating system, works quite differently than standard Windows. The basic assumptions regarding Windows Phone, or a phone, any phone for that matter, is that first, a phone will always have considerably less memory and CPU power than any other laptop or desktop. Second is that you probably would like to concentrate in a phone on one application running and dedicate as much CPU power and as much memory you can for that application. It is a phone. We do one thing at a time. And last, but definitely not least, battery power. We would like, it is a critical issue. We'd like our phone to last for at least a full day of work, and it's not an easy task. Given these assumptions, Windows Phone allows for only one user application to run at any given moment. Please remember, I'm talking about user applications, not operating system processes, which runs in the background. So once we flipped away from one application to the main screen or to another application, that application becomes, it stops immediately, and it might just even cease to exist. It's up to the operating system to decide. Therefore, we have the full CPU power and as much memory as we can for our next application running and we're not wasting unrequired battery power. So there's no real multitasking in Windows Phone. There's almost no need for thread manipulation and scheduling, as this is as only for operating system requirements, and operating system does that. For example, when the phone rings, you would like the operating system to address that as soon as possible. But how do we get back to an application that we ran before, to the exact state we were on that application, as if we would like to have the same experience as if we were doing Alt-Tab instead of Windows? Let's see the diagram illustrating the lifetime of a running Windows Phone application. As you can see, any application has states and events managing its lifetime. A launching application triggers an event, the application launching event, which calls the onNavigated to-page event method. We can subscribe to that method and write our own to that event and write our own code. So right after finishing the user method, the onNavigated to method, the application goes into a running state. That state and stays there, and that state for as long as the user hasn't flipped to the main memory screen or to another application, or if the application closes by itself voluntarily. Leaving the running state is done by either by going into to the dormant state right here, by the deactivated event, or by shutting down the application with the closing event. So you can see that the onNavigated from method is called whenever in any case that we're leaving the application, and the onNavigated to method is called whenever we're going back to the application in any case, okay, in any method. And it is our duty as programmers to write the code that will save the current logical application state within the onNavigated from method, and recall that state from within the onNavigated to method. So this way the user may not be aware to the fact that the application has been dormant, that is idle, but still in memory, which is the fastest way to recall it, or tombstoned, which is that the application has been removed from memory by the operating system and will be recalled from the isolated storage once reactivated. We are using the onNavigated to method in order to load that state, so the user doesn't know really that that's what happened. Okay. There are other implications to such behavior apart from the obvious battery life and performance benefits. One apparent implication is that we cannot have our application stay updated once not running, as we do not have multitasking. Let's say that we have a stock tracking application, some kind of an application that manages stock of merchandise. So I can open that application and see what's going on with my stock, what was the latest transactions, and what is the current stock level. But I would like to go back to the main screen and still be updated, and I would like to know when I go under a certain threshold. I can't do it because I don't have multitasking. We can solve that with live tiles and push notifications, and with the background agents. We'll see all that in the next slides. So what are live tiles? What is a live tile? And the Windows Phone main screen is divided into rich rectangle areas, you can see right here, which are called tiles. Each tile represents an application or application scope. A tile basically defines a URI to that application. This way we can have more than one tile. We could have a primary tile, which directing to the application in general, and a secondary tile that directs us to a sub-page with special parameters with a deeper URI. A tile is not an icon. An icon is a static picture that represents an application to launch. But a tile may display dynamic information that can change during the lifetime of the application or the lifetime of the running Windows Phone operating system. For example, let's see the Outlook tile right here. You can see the number of the unread messages, the current number of the unread messages, and it's being updated all the time. Or the SMS MMS unread messages, or the picture tile, which shows a random picture from the isolated storage. So all that is not enough. Remember the stock trick application I mentioned before. I'd like the tile on the main screen to update, just like I showed you the Outlook tile. A tile is not a running application. A tile is not a running application. The operating system, it's a feature of the operating system, which is being displayed and managed by the operating system. We can change the information that is being displayed by the tile, by the operating system over the tile, but it doesn't require a running application. The application just has to create it. So where's the data coming from? Well, it could come from various sources. First, a running application must create a tile in order for the tile to exist. A running application gives the tile its initial look, and it could terminate or get navigated out of. For now, the tile is really no more than an icon. How do we get it to life? So the creating application may also, before it terminates, may also create something called a background agent before it terminates. This is really pull mode, because the background agent is a piece of code that is scheduled to run every 30 minutes or more. That's a limitation, by the way, every 30 minutes or more. Using such agent, we can, for example, fetch the required information from the internet, or calculate it from within the phone, and decide whether to update the tile or note, send a note to the main screen. I'll show you how to do it according to the latest information acquired. The agent runs our code that decides what to do whenever to do it. So the agent approach is appropriate whenever 30 minutes or more is good enough. For example, for some people, updating the Outlook tile for every 30 minutes is good enough. Not for me. I need to stay updated all the time. But there are other implications, because it is CPU and bandwidth consuming. Every once in a while, we go and we ask the questions. We really nag. We ask the question, do we have anything new to update? Do we have anything new to update? And again. Now, wouldn't it be better, instead of sending unrequired messages through the bandwidth, through our wire, wireless for that case, to have someone else, ask someone else to do that nagging for us and call us whenever there's something new? That would save on battery power, on CPU, and on bandwidth. So the better approach would be push notifications. Like I said, we would like to save on CPU, battery power, and memory. When coming to remote information, meaning information that is produced from within, outside of the phone, we would like to save on bandwidth as well. So we wouldn't like to nag. We would like to create a strong server somewhere on the cloud. It could be my own IIS running somewhere, or my own WCF server, or something that's running on Azure. And that server would do the nagging, the check, would check the information for us and send us messages. So let's say we establish a server somewhere which does the heavy work for us, while our phone is mostly dormant or doing something very important like playing Angry Birds. For example, once something has changed and there's something to send, there's new information, we'd like to send it back to the phone, which is waiting for our message. Now, not the running application is waiting for our message, the operating system is waiting for us, for that message. Let's take a look at that diagram. There it is. Let's take a look at the diagram. Please follow the steps as numbered. At first, we have a running application which requests a push notification URI from what's called the push client service. This is a service that's running on our phone, the operating system service. The push notification service in turn negotiates with the Microsoft push notification service, which is a service running online, a cloud service, for the required URI being returned to the calling application. So we have a unique URI that identifies our phone and application, which is created by the MPNS, and it is being returned to the push notification service, and from that to our application. That was steps 2 and 3. So once successful, the application can send that URI to some kind of cloud service, our own cloud service, the one that we created, the negger, for that matter, the one that would neg for us, and it would that web service would save that URI and do whatever it takes to start checking for the information to be sent. Now the application may close or be navigated out of. Whenever that cloud service decides that there's something to send, it nagged and it found something new, and there's something to send, it will create a payload. And it will use that URI to the MPNS. The URI leads to the MPNS, not to the Windows Phone, for security reasons. It will call, for security and availability reasons, it will call the MPNS and it would send, using that URI, and send the payload. And the MPNS will respond with its own message, with an acknowledgement that the message has been received and that it knows if it does. It will tell us if it knows where the phone is, if it's connected, and if it can be reached. Now, bear in mind that even though the MPNS might say that it's found the phone and it's about to send the message, there's no assurances that the message would get to the phone, and you have no way of knowing that the message has actually been sent and accepted by the running application or the tile. We'll see later. So there are 3 types of notifications that can be sent. There is the toast notification, the raw notification, and the tile notification. Let's talk about them. A toast notification triggers a bold-faced string that displays immediately just after the application icon. It will be shown for 10 seconds unless the user dismisses it by flicking to the right. The user may also tap the toast, thus opening the application that initiated it using a URI that is defined to that toast. It could be any type of deep URI with a parameter, a special parameter. Toast notifications are usually used for immediate messages like the one you can see right here, weather alert, like in order to say something that can't wait. I'd like to tell the user something that cannot wait. I'd like to tell them something. It resembles a pop-up window in standard Windows. We have, in order to send a toast notification, there are properties to that message. We'll see the message later in the demos. The first is the title, which is the it's a bold-faced text to be displayed. Second is the content, which is a non-bold-faced text, which is would be displayed right after the title. And there's another parameter you cannot see here, which is it's called parameter. And parameter is not displayed anywhere, just being sent directly along with the toast message and used by the running application If the user chose to open the application by tapping the toast, it would be sent to the running application to tell it something. Another type of notification is the role notification. A role notification is a custom message sent directly to a running application. Note, a running application. If you send the run notification and the application is not running, it will be ignored. So the run notification is used to send custom information to a running application, such as, for example, traffic status change for a navigation application. Instead of having the application poll for that information, wasting battery power, wasting bandwidth. The third and last type of notification is the tile notification, which is a type of notification that is used to send information directly to a tile that resides on the screen, and without having the application that created it to have to run at that moment. A tap on a tile, by the way, will of course open the application on that very special subpage and parameter that was defined to it. It could be any type of subpage. So let's see the notification structure of a tile. We saw toast messages. Let's see the type of for tile messages. Tile messages define three main properties and three extra properties that we'll see later. The main properties are title, which is a string indicating the title of the application. It must fit into a single line of text and should be not wider than the actual tile. Approximately 15 characters would fit before it will be truncated. Another property is the background image. The background image is an image to display the front of the tile. It is recommended to always have a background image in front of the tile and not leave it transparent. That image can be either JPEG or PNG files. It should weigh not more than 80 kilobytes. Any image weighing more than 80 kilobytes would be ignored. It should be 173 pixels by 173 image. Any image that is wider would be stretched down to fit the dimensions. Whenever we can, we'd prefer to use images from the phone internal storage rather than sending them over the wire for performance and bandwidth. Another one is count or badge, which is a number between 1 and 99. If the number is 0 or not set, the circle will not be displayed. In Windows Phone version 7.1, we could have double-sided tiles that change periodically. For that, we have a few more properties. The first is back title. The same rules for title applies here. The second is background image. Again, the same rules apply. And the last is the back content, which is a string displayed at the back of the tile. And we can fit a little bit more, approximately 40 characters would fit. So let's do a few demos. Let's see some code. The first demo would show. I'll show you how to create a static tile. Then we'll update the tile using a background agent. Then we'll make our application push notification aware and create a server, a notification server. We'll send notifications, tile and toast notifications, react to them, and use double-sided tiles. Okay, for our first demo, if you remember the application I told you about tracking stocks, so I created a small Silverlight application. You can see here. As you can see, I'm not so much of a graphic designer, but it's an application that allows me to see the current transactions. For example, initial stocks of 50 units. 12 units sold, 5 units sold, etc. The current stock level, and it allows me to create a tile. create a tile on the screen. For now, we'll create a static tile. That event, the create tile event, as you can see, if we go further inside, you'll see a lot of code. Okay, not so much, but the first thing to say is that I need to use the Microsoft Phone Shell namespace. Now, on the button event, I create a URI. That URI is the subpage of the secondary tile. A tile, the subpage of the secondary tile has its own URI, so when tapped, it will go to that page. For now, I go to the main page. Another thing to define is the class, the standard data class. Let's go and see its definition. It derives from the shell tile data, which defines the title, and we also have a definition of the count and background image properties. And for double-sided tiles, we also have back title, background image, and back content. Going back to the code, you can see I didn't use a background image for this one. I set the count, which is the badge number, and the title, and I used the class shell tile from that namespace and the static function create in order to send it the navigation URI I created and the data. Let's run it and see what happens. So the emulator is starting now, and you can see my application. Here's my application. It's almost running. Right, it's running. I can see the Silverlight application and the create tile. Clicking it will create the tile. Now you can see that this is the other tile. We have stock level percent and the badge, the count 50, but the primary tile is still there, and I can pin it to start, and you can see that now I have two tiles. This is the primary and this is the secondary one. Okay, so we've created a static tile, and tapping that tile, I go back to the page I defined. But let's go further to background agents, because this is a static tile. I'd like the information to be dynamic. It doesn't change. Nothing changes it. So let's go to the other demo. In this demo, let's go to the main page. Yes. In this demo, I changed it a little bit. Now, again, we can see the current stock level, which is 50% from the initial stock of 50 units, and also I added the threshold percent text box, where I can define a threshold and a percentage where, if the stock goes under that percentage, I'd like to track it. If the stock goes under that percentage, I'd like to be notified. So let's see what's going on here. A little bit more code. I have the click button, and again I created navigational URI. You can see that now it has a parameter. I send myself information. I'd like the agent to know the threshold, so I added a parameter. The subpage has the parameter, and it will be used by the agent. Again, I create the standard standard data. It looks the same, but before I call create, I call my own function, my own method, add background agent. There I used a class. I defined the name of the agent. It's a unique name for the agent to find. You'll see it later. And I used the scheduled action service class, and we can see where it's coming from, the Microsoft Phone Scheduler namespace, which I also used here. And I use it in order to find that task. I wouldn't like to create more than one. Remember that we're limited by the number of agents. So I'd like to find it, and if I find it, I'd like to remove it in order to create a new one. Now I create the task all over again, and I set the name of the task and a description, which is a friendly description. Yes, that's the name. Here's the friendly description, and I added to the scheduled service. It's a static function, and it's a static method. And of course, I didn't write the actual code to deal with the errors here, but you should. But how does it link to the agent? I did not create an agent. So in order to create an agent, here it is. I went to the solution and I added a new project. And that project is a Silverlight for Windows Phone and Microsoft Phone scheduled task agent. That project I created was rendered for me, and most of the code already exists. If I go in here, you'll see that most of the code, and I wrote it right here in the comment, most of it was pre-generated for me. So everything here was generated by the studio, but this is my own code here. This is the only invoke method that would run by the agent. Now, do remember that it would run every 30 minutes, not less. So what I have here, I created the parameter prefix, and I go to shell tile, active tiles. Now we go from the other side. We go to find that tile. How will I find the tile? I use the navigation URI, including the parameter prefix that defines it and differs it from the other tiles. Now I'm looking for it. If I find it, if I don't find it, it means that the tile is not there. It was removed or whatever. It doesn't interest me, and I should remove the agent right now. But I don't do that. I didn't write it here. If I find it, I now create a new shell tile data and I update the tile. Remember that I update the current tile. I gave it 59 for now. This is a sample value. I should get it from somewhere from the internet to produce it from within the phone, which is costly. But I now update, as I said, I update the found tile and using the agent. But also, I might like to send a toast message on certain occasions. For example, if I go under the threshold. So if the threshold has been reached, yeah. So let's see, what I'm doing here is I extract the threshold from the parameter prefix. You remember the parameter prefix I defined earlier. I'm looking for the number here, which is the threshold. I extract it, I find the location, and I try to pass it. If I fail, okay, failing here means that there's no threshold defined, and I do nothing. If I do have a threshold, I check. Excuse me. I check if it's been breached, and I send a toast by using the shell toast class. It's a class within Silverlight, and it creates. We're creating a toast message from within the phone. So again, the tile and the contents stocked when under whatever percentage it is now, and the navigation URI and the toast show. It's just like popping out a message, just like doing message box show. And I do notify complete, and I'm done. I can run it, and I will run it, but the only issue is that we're not going to wait 30 minutes to see it, to wait for it to work. So we'll just see that I define a threshold here. Let's do 30, for example, and track, and it's created. There's a background agent here, but we will not see it running. So we would like to have push notifications, and we would like to see the last demo of push notifications. Let's close this one, and have the actual other server doing the work for us. Now we have two projects here. The first one is, it looks the same really, with a threshold and a track, but if I'll click it and I'll go into the if I'll go to the event, we'll see that I create a navigation URI and I call the register tile for push notification, which does the work for me. Now I have a channel name. Here's the click and navigation URI, and I register. Here it is, and I register. I call the register. Now I use the HTTP notification channel, which is defined within the Microsoft Phone notification namespace, which I'm using here. This is what negotiates. I also use the system service model for WCF. We'll see it later. This is what is used in order to negotiate with the internal service, the push notification service. You see device ID here. I define a device ID that uniquely, it's a unique device ID for my phone, and I save it for later use in order for the MPNS to recognize me, my phone. I save it in the isolated storage. If I find it, I use it. If I don't, I create a new one. See device ID, and if I don't, I create a new one and save it. Now I try to find I try to find an open channel. Again, if I already have a channel open, I'd like to use it. Otherwise, I'd like to create one to the service. The channel is not created instantly. It will take time to create it because everything is asynchronous in Silverlight, and that's I have to register to the channel URI updated event and continue from there. There's also the error occurred event to tell me that something has happened, and I call channel open. I'm done here. If the channel is already open, I'll call subscribe to the notification. We'll see it later. Let's see. Okay, if there's an error, I'll show it on the screen. It doesn't matter right now, but here's what happens when the channel is already open. Now, when the channel, okay, the connection was made, and we have an open channel now. So I do have an open channel. I find it once again because I'm on a different method. I find it by the name, and I bind it to toast and tile messages in order to be able to react to them if I'm running already. Now let's go to subscribe notification. As you can see, I'm using WCF here. I'm trying to reach the server. I did not create the server. I have it on the other project, but this is the server, and it's basic HTTP. I defined the threshold, and I try to pass it from the screen, from the control. If I don't pass it, I just send 0, and I call. Of course, I register to the completed. Again, we're doing ASIC work here, so I register to the event because we're doing async operation. And next, I'll call the set notification. Okay, now let's call the set tile notification async. We didn't see that yet, but once this is we call the cloud service that I created with the Orion parameter and threshold, by the way, the one that we produced. Remember that. Do remember that the cloud service will call the MPNS, so we have the URI created by the MPNS. So now the cloud service, the cloud service call is done. We're checking for errors and cancellations. Of course, we stop if there's an error or cancellation. If everything goes well, we create the tile. I use the background image now. You can see the background image right here. Let's open it. I create a background image of a small box. Here it is, small box, because dealing with boxes here, it's an inventory. And I titled it stock tracker, and I did shell tile create just like I did before. That's all. Now let's see the other side. Let's see the other project, the stock tracker service. Here it is. You can see it's a WCF project. It's a very simple WCF project, and the only thing that it exposes is set tile notification URI in the operation contract, which is how the phone, how to get the MPNS URI and the threshold from the phone. So let's go and see this service implementation right here. You can see that I use single service and single context, and I define the current stock level. I simulate the stock level here. I create a simulator that goes from 100 to 0 and again to 100. So we'll do it every 5 seconds. Here's the pub sub dictionary, because we can register more than one phone, and we would like to know who toasted it. Who we toasted already, would like to toast more than once. Now, since we're using single concurrency, single context mode, we'll only have one instance, and this will be called once. So I start the thread that will do the simulator, and I'm done. Let's see what happens when someone calls us, when a phone registers a URI and threshold through the contract. So I lock the pub sub, because I would like just to guard it, and I just save the information and I write it on the screen. What happens when what happens when the simulator works? Okay, this is the works. We send information to the phone. So let's do it every 5 seconds. I start to, if the stock reaches 0, I'll do it circular, and I clear the toast because I'd like to toast again. Now, if there's if I have subscribers, every 5 seconds, if I have subscribers, I again lock the dictionary and I decrease the stock level. For each subscriber, I'll check if the subscriber crossed the threshold. Okay, this is the threshold. If it did, I'd like to toast it. If it wasn't toasted by now, okay. So I try to send notification. I use the key. Key is the URI, the MPNS URI, and this is the message. And I edit. If I fail to send to the phone, meaning the phone is not connected or the application is not there, or it's not successful because the phone is we would like to unregister and unregister the phone. So I add it to a list of that URIs to subscribe later, and I mark it as toasted. Okay, set tile update again. Oh, I'm sorry for that. Sorry for that again. Wait a minute. This is. Let's see the standard case. The standard case is that it has not been breached. So if I send a simple message with the stock level and nothing, but if we have an alert, I'd like to change the PNG. I'd like to change the background. If would like, it's a different image for threshold breach. So different image, and again, I'd like to use double-sided tiles. This is the moment to do it. Stock level is low, don't forget to update it. We create a double-sided tile. So let's run everything. Oh, I'm sorry. Yeah, let's see. Let's see what happens. How do I send the toast message? I create an XML. You can see that the information is being set here in text 1. And I do send message. We'll see it a little bit later. With tile, again, the XML message. You'll have everything. You have my demos, count and image, and I call send message. The send message really calls upon that URI, the MPNS URI by post, and defines the type of the header of the type of the message I'd like to send, toast or token for tile, and opens the stream and send it. The next step would be to get the response from the MPNS to know what's going on. Was it successful? So we wait for a response, and I write it on the screen for us to know. But if the device connection status is not connected, I return false. Remember, if I return false, it will cause the sending methods to unsubscribe the phone. We unregister it, okay? So we're done here. Now we're done, and we can run everything. Let's change it to 5. Didn't see that it was 10. Yep. So I started the server, and I'll start the Windows phone. Let's put them together and see what's going on, what happens. Here it is, side by side. The application is starting. I'll set the threshold. Let's do it next threshold here, because I'd like to be able to show it to you, so not wait for too long. Let's do 90%. Remember, every 5 seconds it changes. It takes time for the message to go to the MPNS and back, and then be sent. Oh, here it is. We have registration and threshold of 90, and it changes, and you can see the tile is changing. The badge, the count is changing. Now it's 98, and again we're sending to the MPNS 97, and it sends 97 to us. Now the tile is working even if we're not looking at it. If I'll go to the other screen and do something else, let's go to the settings for now. It's working for now, and change the, say it's 94, change the theme to, for example, let's do it teal, and I'll go back, and you see it has been changes from behind the screens. Now what happens when it crosses 90? 90 is our threshold. So let's wait anxiously for 90 and 89, and let's see what's going on. 89, and a toast message should, here it is, a toast message, and the tile has changed to the alert JPEG, and it's a double-sided tile. Here it is, don't forget to restock. It's double-sided now. Okay, let's sum up what we did today. We saw how live tiles bring your main phone screen to life. We saw how we could create them and do it with Silverlight. We learned about background agents and push notifications and how to do remote updates. We saw that with Silverlight, it all adds up very easily. You can do it very easily, very little code, and everything is done very easily. And I'd like also to tell you that XNA games may also have live tiles. So where do we go from here? I'd like to suggest that you go on and understand how tombstoning works, to see how you can create the server under Azure. It would give you a better server, better functioning server, and how to create XNA games with live tiles and push notifications. Resources. The first one is how to schedule the tile updates for Windows Phone. You can see the link right there. The execution model overview for Windows Phone and the code samples for Windows Phone. I'll also upload my code samples, and you'll be able to download them later. So thank you very much, and I'll take your questions now.